Hello everyone, welcome back. In this video, we are going to continue exercise 2.5 of polynomials. We have already completed 1 to 10 questions of this exercise, and in this video, we'll start with 11th question. So in 11th question, you have to factorize this. 27x cube plus y cube plus z cube minus 9xyz. So this we have to factorize. So this type of identity, if you see any expression like this, for this type of expressions, one identity is there. A cube plus b cube plus c cube minus 3abc, it is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. So here we will use this identity to factorize this. So first of all, we have to convert this given expression in this form, because once we have this form, we will use the expanded form and then we can factorize it. So let's try now. So 27, in previous questions also we have done cubes, cube roots and square roots and cubes and squares. So same way we will do here also. So here we have 27x cube. So 27x cube you can write as 3x whole cube. 3x whole cube, why? Because 3x into 3x into 3x is equal to 27x cube. So 3 into 3 is 9, 9 into 3 is 27. X into x is x square into x, it is x cube. So that's why we have written it like this, because we need this form, that's why. So 27x cube, I have written it as 3x whole cube plus y cube as it is, we can write it, and z cube also as it is, we can write. So in this expression, see, just take help from this. This is 3abc. Write minus sign as it is. 3 also you can write as it is. Now a is the first expression. So this is your first expression, 3x. So just write in place of a, write 3x. B is your second expression, which is y. So this whole we will write in this way, whole cube. So second expression is y. So here we can write y. Third expression, now in place of c, third expression, which is z. So we will write. So here also you can see a cube plus b cube plus c cube minus 3abc. So this is a cube, this is b cube, this is c cube minus 3abc. So now we have got this form. So once you got this form, now we can use this expansion and we'll factorize. So if you see, you can see now you have got the values of a, b and c. So a is 3x, b it is y and c it is z. First three expressions, these are the values of a, b and c. So now you have got the values of a, b and c. We can substitute the values in this expression. So a plus b plus c, we can write it as 3x plus y plus z. Then a square is a is 3x, so 3x whole square plus b square, b is y, so y whole square plus c square, c is z, so z square minus ab, a is 3x, b is y minus bc, b is y and c is z minus ca, c is z, a is 3x. So this dot, it's a sign of multiplication, so I am writing. If you want, you can write a sign of multiplication also. It's both are the same things. So this expression we can write it as it is, because all are different terms, so we cannot do anything. We have to write in this way, 3x plus y plus z. 3x square means 3x into 3x. 3 into 3 is 9, x into x is x square, so 9x square. 3x square is equal to 9x square. Y whole square, it is equals to y square. Z square is equals to z square minus 3xy. Variables, they can get multiplied, so directly you can write minus 3xy minus yz minus 3zx. So this is the factorization of this, because here you can see all the terms are different, so only like terms can be added or subtracted. Being all different terms, we cannot solve it further. So this is the factorization of this expression. We have made use of this identity. So only thing you have to convert it into this form, see the values of a, b and c, then we can substitute in this expression. Now let's do the next question. In the 12th question, we have to verify this expression is equal to this. So let's do it. So this is left hand side and this is right hand side of the equation. We have to prove that left hand side is equals to right hand side. So let's start with left hand side first. So left hand side of the equation, it is x cube plus y cube plus z cube minus 3xyz. So this thing, see, in the previous question we have used one identity. So let's repeat that identity, that was a cube, or let's write it in the form of xyz. So x cube plus y cube plus z cube minus 3xyz. See this same expression, this one, it is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. So this thing, it is equal to this. So let's write it down. So directly we can write left hand side, it is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. So you can mention the reason because of this identity. So left hand side you have got equal to this expression. Now let's do the right hand side. So let's find out the value of right hand side. Right hand side of the equation, it is equal to 1 by 2 into x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. So here directly cube is not there, but these expressions are there in which whole square is there, and the identity related to whole square we have already done in this exercise. So let's recall that identity. A minus b whole cube. A is a minus b whole square, sorry. So it was a square minus 2ab plus b square. So here for all these three terms, see these are in this form, a minus b whole square, all are in this whole square form. So we'll use this identity for all these three expressions. 1 by 2 into x plus y plus z into x minus y whole square. So here your a and b is x and y. So accordingly we will use. So we will write x square minus 2xy plus y square. See, I have just substituted a and b as x and y as per this expression. Now let's do for the second expression. In second expression, if you see, x and y and z are your a and b. So accordingly we have to substitute the values of a and b in this expression. So we can write y square minus 2yz plus z square. Now in this expression we have to use the same identity because it is also in square form. So here a and b are z and x. So this plus sign as it is we have to write. See, all these plus signs as it is we are writing. If you want you can put these brackets also for your understanding. Now this one, see, z and x we have to put in this expression. So z square minus 2 zx plus x square. So bracket, if you want you can put brackets. Now we can remove the brackets. Actually we don't have to write the brackets. If you want, in next step, in this step you can write the brackets and you can remove it in next step. So here itself I am going to remove. Now let's find out if any like terms are there, because like terms can be added and subtracted. So this term we can write as it is, x plus y plus z. Here if you see x square and x square, both are like terms, so we can add x square plus x square, it is 2x square. Now this term as it is I can write, because you can see no like term is there, 2xy. All the terms are different, so as it is we can write 2xy. Now y square plus y square. So y square and y square, two terms are there, so directly we can add 2y square. Y square plus y square, it will become 2y square. Now this term, no like term is there, so we can write this term as it is. Now z and z. Z square plus z square, it will become 2z square minus 2zx. Now you just have to see one thing. See, 2 is present in all the terms. So what we will do, instead of writing 2 so many times, we will just write 2 outside this bracket. We'll just take 2 common and write it here. We will write. You can write here also, it's your wish. See, 2 I am just taking out common. If you again multiply, the terms will become same. It will become 2x square, it will become 2xy, 2y square, because whenever any term is written outside the bracket, so this term will get multiplied with each of the term which is present inside the bracket. So I have just written outside. Now this 2 and this 2, they will get cancelled. So I am left with x plus y plus z into x square. So I'll just write these terms together, x square plus y square plus z square minus xy minus yz minus zx. Now at the starting, left hand side, once we solved, it was also equal to this term, this expression. So hence it is proved it is also equal to left hand side. So you can write left hand side, it is equals to right hand side, hence verified. Now let's do the next question. In question number 13, it's given if x plus y plus z equals to 0, show that x cube plus y cube plus z cube, it is equal to 3xyz. So again same identity we have to use, which we have already used in previous 2 questions. So this is x cube plus y cube plus z cube minus 3xyz, it is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. So this is we are going to use. So how to use? It's given x plus y plus z equals to 0. So you can start from here. Directly you can write the identity, x cube plus y cube plus z cube minus 3xyz equal to, now this thing x plus y plus z, it is equals to 0. So we can write 0 in place of this. 0 into x square plus y square plus z square minus xy minus yz minus zx. So here you can mention because x plus y plus z equals to 0. So that's why we have written 0 over here. X cube plus y cube plus z cube minus 3xyz equals to anything, if it is multiplied with 0, it is equal to 0. So 0 into this term, it will be equal to 0. Now you can see x cube plus y cube plus z cube, it just shift this to other side. So minus 3xyz, if you are shifting to other side, it will be changed to plus xyz, plus 3xyz. So plus sign, if you want you can write, no need to write, because the number itself is a positive number. So now you have got x cube plus y cube plus z cube equals to 3xyz. So that's what you had to prove. So you can write hence proved. Now let's do the next question. In question number 14th, it's given without actually calculating the cubes. See, cubes are there, so we don't have to actually calculate the cubes. We have to find the value of this expression without actually finding the cubes. So this question we have to take little help from the previous question. In previous question we have already proved if a plus b or x plus y, so in any form you can write. So if x plus y plus z, it is equal to 0, then x cube plus y cube plus z cube, it is equal to 3xyz. So this is what we have to this is what we have already proved in the previous question. So this we are going to use in this question. So first of all we have to check. See, this is our x, this is y, and this is z. So we have to check whether their sum is equal to 0 or not. So if it is equal to 0, then directly we can use this expression. So let's see. So we have minus 12 plus 7 plus 5. So this is our x plus y plus z. So minus 12 plus 7, minus plus is minus with a number which is with a bigger number. So 12 minus 7 is a 5, and 12 is a bigger number with 12 minus sign is there. So we'll write minus sign with our answer. Minus 5 plus 5. So minus 5 plus 5, both they will get cancelled and will get 0. Now you can see our terms x plus y plus z, it is equal to 0. So due to which we can use this result. So this expression x cube plus y cube plus z cube, you can see this form is already given to us, x cube plus y cube plus z cube. So we can write, so at the side you can mention because. So these reasons you can mention, this is also you have to show. After showing this you can mention therefore x cube plus, since x plus y plus z is equals to 0, therefore x cube plus y cube plus z cube, it is equal to 3 into x plus x into y into z. So that's what we are going to do now. 3 into x, which is 12, into y, which is 7, into z. First of all you have to start from here, you have to show it is 0, then you have to write therefore this expression is equal to 3xy, then we are doing this step. So 3 into minus 12, 3 into minus 12, it is minus 36, into 7 into 5, 35. So we can do multiplication, 35 into 36. So multiplication I am doing, so it is 1260 with the minus sign, because only one minus sign is there. So only one minus sign is there in multiplication, with their answer also multiplication sign, minus sign will come. And you can see, you can actually do the multiplication, you can actually find the cubes of these three numbers and then you can add, you will see you will get the same answer. Now this question, it has two parts. One part I have already done for you, second part also same way you have to do. First of all you have to check whether your x plus y plus z, it is equal to 0, and once it comes equal to 0, then you can use this identity directly. Now let's do the next question. In 15th question, we have to find the expressions for length and breadth for a given area. So two parts are there. One part I will do along with you, and second part you have to try yourself. Both the parts are same method we have to do while solving this expression. So let's start. So this expression is of area of rectangle, and we know area of rectangle, it is equal to length into breadth, length into breadth. So we can write length into breadth, area it is already given this expression, so we can write 25a square minus 35a plus 12. So now if you see this expression, see this is quadratic polynomial. The highest degree of the variable is 2. So which means this is quadratic polynomial. We just have to factorize it. And we will factorize this expression by splitting the middle term. Splitting the middle term in a very detailed way I have already explained while discussing factor theorem. So if you have not seen that video, I have shared the link in the description. Just go through that video also. But here also I will explain. You just have to see that video also and understand how to split the middle term in a better way. So let's back to the question now. So this expression will start the same way. Splitting the middle term means this term we have to split in such a way that its product should be equal to first and last term, or its addition and subtraction should be equal to middle term. So let's start. So first of all, write the product of first and last term. So first term is 25. We don't have to write the variable, so I will write only 25, and last term is 12. So this is 300. Middle term is minus 35. Now minus 35 I have to split in such a way that only in two numbers, that the product of those two numbers, they are equal to 300, or the product it is equal to 300, and its addition or subtraction of those two numbers it is equal to minus 35. So before that you can make the factors if you want. 300. So 300, it's a big number, so we can try with 20. 20 into 15 we know it's 300. 15 into 1 is 15. Now we know 20 if we multiply with 15 we will get 300. So product we are getting 300. But if you are adding or subtracting, on adding 20 plus 15 you will get 35, but you need minus 35. So one thing is clear that we have to add. So what we can do, we can take minus 20 and minus 15 instead of plus 20 and plus 15, because minus minus is also plus with a minus sign. So minus 20 minus 15 it is equal to minus 35, and if you multiply also minus 20 into minus 15, you can see minus and minus sign will get cancelled, and your product it is equal to 300, which is equal to the product of first and last term. So we have got the two numbers minus 20 and minus 15. So we will split the middle term into these two numbers. So let's do 25a square we will write as it is. So instead of minus 35 now we have to write these two numbers. So minus 20a minus 15a plus 12. See, minus 20 and minus 15 it is equal to minus 35a. So we just have splitted the middle term. Now we can make two pairs. This is one pair and this is one pair. So we have to take out common. So out of, if you want in short way we can write first. Short means like 25 we can write it as 5a into 5a. This 5 into 5 is 25, a into a is a square. So it will be 25a square. 20 you can write as 5a into 4, because a is also there. So 5, because 5 into 4 is 20. So 20a you will get. So if you write 20 as 5 into 4. Now in this pair, 15 you can write 3 into 5. A you can write here, a is also there. 12 again we can write 3 into 4. Why we are writing in this way? This is one pair, this is one pair, because we have to take out common terms. So here 5a is present in both the terms. So 5a is common, so I will write it out, and inside I will write the remaining terms. So 5a I am left with, and here 4, minus sign as it is. So 5a minus 4. Now this minus sign as it is. Here 3 is present in both. So 3 I will write out, and one thing I have already explained to you, whenever minus sign is there outside the bracket, inside sign will get changed. So just write the sign, change sign first so that you won't make any mistake. So here write the remaining terms. This is 5a minus 4. Minus sign outside, so inside sign will get changed. So why it will get changed? Because once you open the bracket, minus and minus, again it will be changed to plus sign. So that's why always whenever minus sign is there outside the bracket, we have to change. And now you can see this term and this term, both the terms are same. And if you are getting both these terms same, that means your sum is correct till here. Now you can write same term out. Again we can take out common term and remaining numbers we can write 5a minus 3. So two factors we have got, 5a minus 4 and 5a minus 3. So here it was L into B. So you can write, because these terms are also getting multiplied, here the sign of multiplication is there and these two are also getting multiplied. So you can write possible expressions of length and breadth are 5a minus 4 and 5a minus 3, because we had to find the expressions. So these expressions are the possible expressions of length and breadth. So same way next part also you have to do by splitting the middle term. You have to make the factors and those factors will be the length and breadth. Now let's do the last question of this exercise. In question number 16th, you have to find the possible dimensions of cuboid whose volumes are given to you. So dimensions of cuboid are length, breadth and height. So three dimensions you have to find. So volume of cuboid, it is also already given to you, this expression 3x square minus 12. And the formula of volume of cuboid you can write here, length into breadth into height. So this is equal to 3x square minus 12. Now we'll just write this expression in more simpler form. It is 3x square minus 12x. So you can write 3 into x minus 12, again we can write as 3 into 4 into x. Now one by one we'll take out the common terms. So first of all you can see 3 is common. So 3 I can write out, remaining terms I will write as it is, into x minus, so here it is 4 into x. Now again if we see, x is common in both the terms, so we will write x out. Remaining terms x and 4 we can write inside now, so it is x minus 4. So here we have to keep on writing L into B into H, here also L into B into H. So if you see this expression, see L, this one, three terms we have got, B, this one and H, this one. So you can write length is equals to 3, breadth is equals to x and height is equals to x minus 4. So these are the dimensions of the given, cuboid. Now let's do the second part. In the next expression, again volume is given to us, it is 12ky square plus 8ky minus 20k. So we have to find the dimensions of cuboid. Dimensions of cuboid means again we have to find length, breadth and height. So we can write volume, it is equals to length into breadth into height, which is equal to this expression 12ky square plus 8ky minus 20k. So now let's find it out, or let's take out the common term out. So this is 12. 12 we can write 4 into 3 ky square. 8 we can write 4 into 2 ky. 20 we can write 4 into 5k. So I have just written in simpler form. Now we can see 4k, 4k and 4k. 4k is present in all the three terms, so I will write 4k out. Remaining terms I will write now. So 3y square plus 2y. See, only because 4k I have already written out. So remaining terms you have to write now. Minus 5. So if you see this expression again it is quadratic equation. See, the variable is y and the highest degree of variable is 2, which means it is quadratic equation. So this quadratic equation we can solve by splitting the middle term. Splitting the middle term, same way we have to do. First we will write product of first and last term. So product of first and last term is 3 into minus 5, which is minus 15. Now we can write the middle term, which is 2. So we have to split the middle term in such a way that its product should be equal to this number and its addition or subtraction should be equal to this. So let's try with these two numbers. So minus 5 or because we need plus 2. So we can try 5 minus 3. 5 minus 3 we know it is 2. And 5 into minus 3 it will be equal to minus 15. So now if we choose these two numbers 5 and minus 3, our requirements are fulfilled. You can see 5 into minus 3 it is minus 15, which is the product of first and last term, and 5 minus 3 it is equal to 2, which is our middle term. So we can split middle term into 5 and minus 3. So 3y square, 2 we can write as, so here minus 3, because 3 we can take common, so we can write minus 3 plus 5y minus 5. So why I have written 3 here? Because 3 and 3 again I can take common. I have to make pairs and I can take out the common numbers easily. 4k. So 3y is present in both, so I will write 3y outside and remaining terms we can write inside. So 1y I have written out, so only 1y will be there. So 3y complete term I have written out, so it is only 1 I have to write now. You can see if you multiply again it will become 3y square minus 3y. Now plus, so 5 is present in both, so 5 we can take out. So remaining terms we can write y minus 1. Because 5 if you have taken out, so here 1. You can check by multiplying, so 5 into y it will be 5y minus 5 into 1 it will be 5. So again one thing, this term and this both are same, which means your expression is correct till here. Now here we can see same thing, we can write 4k into, see this thing we can write, we can take common now, y minus 1 and remaining terms we can write now. So 3y plus 5. So now we can write 4k into y minus 1 and 3y plus 5. So which is equal to length into breadth into height. So one term is length, this is breadth and this is height. So length you can write it is equal to 4k. Breadth you can write is equal to y minus 1 and height you can write equal to 3y plus 5. So I am happy to inform you that we have finished the complete chapter of polynomials, and I am sure you have understood the concept, you have liked the videos. So do share, do subscribe. Thank you so much for watching the video. See you in my next video with some new topic.